Welcome. In this session, we'll talk about the mesh analysis. Okay. Now we know mesh analysis is based on the idea of KVL. Okay. So in order to understand this mesh analysis in Phasor domain, let's start with an example. Suppose we have a circuit, a resistor connected to an inductor like this. Similarly, a capacitor and a dependent voltage source. Independent voltage source. So the values of these elements are the value of this voltage source is 10 cosine 10 to the power of 3t volts, and this is a 3 ohm resistor, 4 millihenry inductor, 500 microfarad capacitor, and the value of this dependent source is controlled by current I1, where I1 is the current flowing in this mesh and I2 is flowing in this mesh. Our goal is to find I1 and I2. Our goal is to find I1 and I2, small I1 and small I2. Now, in order to find this I1 and I2, what we will do? We'll use mesh analysis. But before we apply mesh analysis to this directly in time domain, we'll convert it into frequency domain or phasor domain. So we'll draw the phasor domain of phasor equivalent of this circuit. A resistor we will replace with its phasor equivalent. Similarly, inductor will be replaced by its phasor equivalent. And there is a capacitor here. So we have a resistor, capacitor, a voltage source. So voltage source will be replaced by phasor equivalent of 10 at an angle of 0. Why 10 at an angle of 0? Because the phase here is 0. 3 ohm resistor will be replaced by 3 ohm. 4 millihenry inductor. So 4 millihenry inductor will be replaced by J omega L. J, how much is omega? 10 to the power of 3. That is 1000. And L is how much? 4 millihenry. Millihenry is 10 to the power of minus 3 Henry. So if you simplify this, 10 to the power of 3, 10 to the power of minus 3 will cancel. So we are left with 4J. Similarly, 500 microfarad capacitor will be replaced by the impedance 1 by J omega C. That will be 1 J 10 to the power of 3. Capacitance is 500 microfarad. 500 microfarad is 510 to the power of minus 6 farads. That is same as if you multiply this, it will be 0.5, 0.5, 1 by 0.5 J, that will be 2J, minus 2J, because J will become minus J. So inductor will be replaced by 4J, capacitor will be replaced by minus 2J, and dependent current source will be replaced by capital 2I1 capital, where I1 is the phasor current flowing here in this mesh, and I2 is the current flowing this. So we have how many meshes? 2 meshes here, mesh 1 and mesh 2. So what we'll do, we'll write the KVL equation in mesh 1 and mesh 2 and solve for capital I1 and capital I2, which is the phasor equivalent of small I1 and small I2. Once we find capital I1 and capital I2, we'll be able to write the small I1 and small I2. So what we'll do, using KVL in mesh 1, using KVL in mesh 1, we have, let's start from this point. So if we traverse this mesh 1 from this point, what we'll get? We'll get a voltage source first, and value of this voltage source is minus 10 at an angle of 0. Then we encounter 3 ohm resistor, impedance is 3. Current flowing through this branch is capital I1, so 3I1. Then we encounter 4 inductor with an impedance 4J. So again, same concept. If we are in mesh 1, so we'll say 4J, I1 minus I2, where I1 minus I2 is the current flowing in branch 4J impedance. Okay. Now, so sum of these voltages will be equal to 0. This is a voltage drop, this is a voltage drop, this is a voltage drop. Let me simplify this. So 10 at an angle of 0 is simply 10. So you can write this as 10 plus 3 I1 plus 4j I1 minus 4j I2. This is equal to 0. So we can simplify this further. So this will be simply 3 plus 4j, taking I1 common, minus 4j I2 is equal to 10. So this is our equation 1 that we obtained from mesh 1. Now let's apply KVL in mesh 2. So if we apply KVL in mesh 2, what we have first, we have this element. Let's start from this point and go like this. So we have a 4j impedance. So 4j impedance. And since we are in mesh 2, we'll write I2 minus I1. Okay, as already explained in the case of resistances. If you are in mesh 1, write I1 minus I2. If you are in mesh 2, right, I2 minus I1. That will take care of the plus minus sign. Okay, plus. Then we encounter the next element is minus 2j. Current flowing is simply I2. Then we have a voltage source. The value of this voltage is simply 2I1. So sum of the three voltage is equal to 0. Let's simplify this further. So this I can write as 4j I1 minus 4j I2 minus 2j I1 plus 2 I1 is equal to 0. So if we simplify this, we have 4j I1 minus 2j I1. How much is that? That is 2j I1. Then we have plus 2I1. Then we have I2 minus 4j I2 is equal to 0. Please check these calculations one more time. Verify these yourself. So we'll write R 2j and then this, right? Okay, I think I have forgotten one term here. This term. This is actually I2. Okay, I have written this wrong. Okay, I think I have done this wrong here. Okay, this is minus 2 2j I2 plus 2I1 is equal to 0. So if we simplify this, this is 4j I1 and 2I1. So if we combine this, we write 4j plus 2I1. Then we have minus 2j minus 4j. Again, I think I have written this wrong. I think this is wrong. In this equation, I have written wrongly. Please check this. So this will be 4j I2, then 4j I1 minus 2j I2 plus 2I1 is equal to 0. Now what we have here, we have 4j I2 and 2j I2. How much is that? That is 2j I2. And then we have minus 4j, that I can write as minus 2j, taking 2 common, plus 1 I1 is equal to 0. So if we take this on the right hand side, so I2 will be equal to, so 2j I2 is equal to 2j plus I1 multiplied by I1. Okay, so what we have here, 2 and 2 cancels. So I2 we can write as I2 dividing both sides by 2j. So if we divide both sides by 2j, 2j and 2j cancels. 2 and 2 cancels. We are left with 1 plus 2j divided by j multiplied by I1. Now if we take this j on the numerator side, so it will be minus j. So multiplying these equations by minus j, we are left with minus j minus 2j square I1. Okay, j square is 1, so this will be 2 minus j I1. So I2 is this. So this is our equation 2. Now substituting equation 2 in equation 1. So what we will get? So equation 1 is 3 plus 4j, I think. Yes, 3 plus 4j I1 minus 4j I2 is equal to 10. Let me check one more time. Minus 4j I2, 10. Okay. Substituting the value of I2, so this will be simply R 3 plus 4j I1 minus 4j 2 minus j I1 is equal to 10. So we can simplify this. So this will be 3 plus 4j I1 minus 2 4s are 8. So it will be 8j. Then 4j square minus minus is plus. Then it will be again minus. So 4. Okay. And outside, let me write minus outside. So this will be I1. Please check the calculations here. So this will be, first of all, this is 4 2 is 8. Then 4j, j square, that will be minus, and this is correct. Okay. Now, taking I common from these two, where 3 minus 4 is minus 1. So this will be minus 1 minus 4j. 4j minus 8j is minus 4j. Please check the calculations one more time. Or I1 will be simply equal to 10 divided by minus 1 minus 4j. Please check the calculations one more time. Maybe I messed it. So what is the relationship between I1 and I2? Let me confirm this one more time. And then 4j. So I2 is simply I2 is 1. 1. I2 is 2 minus j. I think this is correct. Okay. All right. So let me please check the calculations one more time. So let's convert this into the phasor form now. So this is 1. What is the phasor equivalent of minus 1 minus j? Minus 1 minus j can be simply written as 1 square plus 4 is 16. So this is 4.123 at an angle of, now this lies in the third quadrant. So we'll say tan inverse 4 is 75.96. Okay, that this will be equal to not 75. I don't think so. This will be 75. And this is 10 third plus 180 degrees. That is 222. And that will be 255.96 degrees. And that, okay, this will be plus. So this will be simply 10 divided by 4.123. And that comes out to be 2.425 at an angle of minus 255.96 degrees. So this is the phasor current I1. Okay. Now, similarly, we can write, similarly, I2 is 2 minus j I1. I2 is 2 minus j I1. Substituting the value of I1. So 2 minus j I1. We'll write this in polar form. I think there is something wrong with this value here. Please check the calculations One more time, verify this. Now this is in rectangle form, this is in polar form. Let's convert both into this polar form. So this will be 1 plus 4 under root of 5 comes out to be 2.23 at an angle of tan inverse -1 divided by 2. That is minus 26.56 degrees multiplied by 2.425 at an angle of mine. There is something wrong with my I1. Please check this value again. So I2 will be simply equal to 2.23 multiplied by 2.425. Answer is 5.407 at an angle of minus 26.56 minus 250.96. Angles will add simply minus 282.52 degrees. Please check the value of these quantities. So this is in ampere. So what is our I1? I1 is simply 2.425 at an angle of minus 2.255.96 degrees amperes, and I2 is 5.407 at an angle of minus 2.52 degrees. Okay, this is in phasor form. So we can write the time domain from this. Amplitude is 4.235. Cosine of what's our this source? Source is cosine of 10 to the power of 3t. So we can convert it. We can convert it. This will be simply cosine of 10 to the power of 3 plus this is minus. So let me write minus directly. Minus 255.96 degrees amperes, and I2t will be simply equal to 5.407 cosine of 10 to the power of 3t minus 282.52 degrees amperes. Okay, these values are in phasor form. These are in the time domain equivalent. Okay, so this is the answer to this problem. Okay, our goal was to find the mesh currents I1 and I2. What we did, we converted the circuit into the phasor form. Then we wrote the KVL for the two meshes, solved for I1, capital I1 and I2. We got the answer here, and then we converted the phasor currents to time domain. Okay, let's consider one more problem. Let's consider one more problem. Very simple problem. Let's say we have a mesh circuit like this. This is a resistor. Then there is a current source here. Then there is a capacitor. And then there is an inductor here. And there is one more branch here. So there is a resistor here. And there is one more resistor here. Let me write the value of the components. So this time we are directly given the circuit in phasor domain. This is a voltage source. There is a current source here, 3 at an angle of 0. The impedance of the capacitor is minus J. Resistance is 1 ohm. Impedance of this element is J. Impedance of resistor is 1 ohm. And impedance of this resistor is 1 ohm. Our goal is to find the mesh currents I1, I3, and I2. So our goal is to find the phasor mesh currents. Our goal is to find I1, I2, and I3. Are these currents in phasor form? Okay, so let's start. What we'll do, we'll use mesh analysis. But if you look at the mesh 1 and mesh 2 here, mesh 1 is this, mesh 2 is this. There's a current source in between. So when we apply KVL to this mesh, we won't be able to apply the KVL at this current source, 3 ampere current source. Why not? Because we don't know the voltage across this 3 ampere current source. So how do we solve this problem? If we write KVL for this, we won't be able to write the KVL. So in order to solve this problem, what we do, we introduce the concept of super mesh. What's a super mesh? Super mesh is a combination of two or more than two meshes. Okay. So we'll introduce the concept of super mesh. Yeah. Super mesh means simply the combination of two, three. Means we consider these two or more than two meshes as a single mesh. So what we'll do, we'll assume that mesh 1 and mesh 2 is a super mesh and apply the KVL for the super. So what we'll do, we'll apply the KVL like this, and so we'll assume this is a single mesh and apply the KVL like this. Okay. Okay, let me write the KVL for super mesh first. So KVL for super mesh. Okay, first of all, we encounter if we start from this point, we have a voltage source 5 at an angle of 0 voltage source. Then we have a 1 ohm resistor here. So then V1, I1 minus I2, I1 minus I3, sorry. Why? Because we are in mesh 1, or super mesh 1. Plus, then we encounter this resistor here. So the voltage drop here will be 1 into I2 minus I3 because the current here flowing is I2. Okay. Then we encounter this 1 ohm resistor. Voltage drop will be I2 multiplied by 1. I2 multiplied by 1. That's it. Okay, so sum of these voltage drops is equal to 0. So if we simplify this, we can write it as 5 at an angle of 0 plus I1 minus I3 plus I2 minus I3 plus I2. Now 5 at an angle of 0 is simply 5. 5 plus how many I1s we have? I1. Then we have I2 that is 2I2. Then we have minus 2I. Please check the calculations yourself. This is our equation 1. Okay, this is our equation 1. We have I1 plus 2I2 minus 2I3 plus 5. Okay, now we'll write the KVL for mesh 3. So we have written the KVL for super mesh. Now we'll write the KVL for mesh 3. So let's suppose we start with this point and move in the this clockwise direction in this mesh. So we have, first of all, we have a 1 ohm resistor and the current will be I3 minus I1. Why I3 minus I1? Because we are in mesh 3, so we'll consider I3 minus I1. Then we have impedance J and the current flowing here is simply I3. There is only one current flowing in this I3. And then we have 1 ohm resistor. And then we have 1 ohm resistor and the current is I3 minus I2. Why I3 minus I2? Because we are in mesh 3. Okay. All right. So let me simplify this. This is I3 minus I1 plus GI3 plus I3 minus I2 is equal to 0. So we have I3 and GI3. So that is 2I3 minus GI3 minus I1 minus I2 is equal to 0. So this is our equation 2. This is our equation 2. Please check the calculations one more time. So I have written this correctly. I3 minus I1. I hope I have written this correctly. I3 minus JI3 plus I3. And we have two resistances here. I should have written 2I3. 2I3, JI3, I1, I2. Please check the calculations one more time. So we can write this as 2 minus J I3 minus I1. Let me write I2 on this side. So this will be second equation. This will be our second equation. Okay. Now we have two equations and three unknowns. So this is a difficult task to solve and analytically. So we need one more equation. Now, how we are going to write one more equation from this mesh? Now, if you look at this branch, that is the current source, 3 ampere current source, which is in this 3 ampere current source, the current is going in the downward direction. Now, if you apply KCL on this branch, right, KCL is applicable at any point, branch or node. So if you apply KCL at this branch, I1 minus I2 will be equal to 3. Why I1 minus I3? Because the current is following the direction of, because I1 is following the direction of current. So it will be I1 minus I2 will be equal to 3 at an angle of 0. That will give us I1 will be equal to, I think, I2 plus 3 at an angle of 0 is simply 3. Okay, so this is our third equation. Okay, so from this, let me write it like this. I can write as, let me take I2 on the other side. So I1 minus 3 will be equal to I2. 3 at an angle of 0 is simply 3. So this is our third equation. Now substituting third equation in first and second, what we will get from this? If we write equation 3 in equation 1 is 5 plus, what is equation 1? I1 plus 2I1, 2I2 minus 2I3 is equal to 0. So if we substitute value of I2, what we'll get from this? 5 plus I1 plus twice I1 minus I3. I hope I have done this right. Which one will eliminate first? I think we'll write this in terms of I2. That will make our job easy. So I2 will be I1, sorry. I1 will be simply equal to 3 plus I2. This is our equation 3. Now substituting the value of I1 from equation 3 to equation 1. Equation 1 is written here. I1 is 3 plus I2 plus 2I2 minus 2I3 is equal to 0. So this gives us, I hope I have written this right correctly. So this is 8 plus 3I2 minus 2I3 is equal to 0. Now we'll call this as equation 4. Similarly, substituting equation 3 in equation 2. So equation 3 and equation 2. What is our equation 2? 2 minus J I3 minus I1 is equal to I2. Is equal to I2. Now substituting the value of I1 from equation 3. So you can write it as 2 minus J I3 minus, what is this equal to? 3 plus I2. That will be equal to, okay. So we can simplify this as 2 minus J I3 minus 3 minus I2 is equal to I2. So if we take I2 on the minus I2 on the right hand side, what we'll get? I3 minus 3 I2 plus I2, right? So we have on the left hand side, we have I2 plus I2, that is 2 I2 will be equal to, I think 2 minus J. This is 2 minus J I3 minus 3. So from this, what we'll get I2 will be equal to 2 minus J I3 minus 3 divided by 2. So this is our equation fifth. Okay, now we have equation 4 and equation 5. We have only two unknowns in these two quantities. So substituting the value of I2 from equation 5 to equation 4. So equation 4 is 8 plus 3I2 minus 2I3 is equal to 0. So substituting the value of I2. So this will be 8 plus 3. So this is 2 minus J I3 minus 3 divided by 2 minus 2 I3 is equal to 0. So if you multiply both sides to this equation by 2, we'll get 16 plus 16 plus 3 into 2 minus J I3 minus 3 minus 4I3. Now we have only one unknown in this equation. We can solve this equation. So this is 6 minus 3J multiplied by I3 minus 9 minus 4 I3 is equal to 0. So 16 minus 9 is 16 minus 9 is simply how much? 7 plus 6I3 here minus 4I3. That will be 2 minus 3J I3. Recheck the calculations one more time. So this will give us simply I3 will be equal to minus 7 divided by 2 minus 3J. 2 minus 3J. Please check this one more time and verify the calculations yourself. So I3 will be equal to minus 7 divided by, we can write this in the Phasor form, 2 minus 3. Okay, we can write in the Phasor form. So that will be equal to 4 under root of 4 plus 9. That is 3.605 at an angle of tan inverse minus 3 divided by 2. That is 56 minus 56.309 degrees. So if we simplify this, so 7 divided, please check the calculations one more time. I think I did this calculation mistake in previous problem. And this will be 56.903. So this is the answer. Please check the calculations if these are correct or incorrect. Okay, this is our I3. Now, what is the relationship between I3 and I2? So I3 is this. So we can write it as substituting the value of I3 into, so I2 is how much? It is 2 minus J I3, 2 minus J I3, I3 minus 3 divided by 2. Now I3 is how much in terms, we'll substitute this one. So this will be simply 2 minus J I3 is minus 7 divided by 2 minus 3J minus 3 divided by 2. So what's this value equaled? Minus 14 plus 7J. We do the cross multiplication, it will be minus 6 plus 9J divided by 2 into 2 minus 3J. So if we simplify this, minus 14 minus 6 is minus 20. And then we have 7 plus 9j, that is 7j plus 9j is 16j divided by 2 into 2 minus 3j. So this I2 we can write as 2 minus, yes, this will be 10. If you divide numerator and denominator by 2, that will be 8j divided by 2 minus 3j. Please check the calculations one more time. Now we can write this in the polar form. So what is the polar equivalent of numerator? Polar equivalent of numerator is simply 12.806 and this is minus 10. So the angle is 141.34 degrees divided by, what is the phasor equivalent of this? Phasor equivalent of this is 56 minus 56.309 degrees. So if you simplify I2 will be simply equal to 12.806 divided by 3.605. That comes out to be 3.552 at an angle of 141.34 plus, it will be plus 56 because it is minus on the denominator side. So it will be 197.649 degrees amperes. So this is the value of I2 current. Similarly, I1 will, what is the relationship between I1 and I2? I1 is simply how much? I1 from this equation is 3 plus I2. 3 plus I2. I2 is how much? I2 is minus 10 plus 8j. So 3 plus minus 10 plus 8j divided by 2 minus 3j. If you simplify this, this will be simply equal to 6 minus 9j minus 10 plus 8j divided by 2 minus 3j. So if you simplify this, this will be minus 4 minus j divided by 2 minus 3j. So I1 will be equal to, you can write this in polar form as 14 degrees. So what is the equivalent of denominator in polar form? 3.605 at an angle of 10 angle of, I think this is incorrect, this angle, because this is in third quadrant, so this will be tan inverse 1 divided plus 180. I think this should be 194.03 degrees. And then this is tan inverse minus 3 divided by 2, that is minus 56.309 degrees. So what will be I3? I3 is simply 4.12 divided by 3.605, that comes out to be 1.246 at an angle of 194.03 plus 56.309. That is 250.339 degrees. So this is the phasor current I3. So what we needed to do in this problem, we needed to find the mesh currents I1, I2, and phasor currents this time. Okay. And in this, we also learned the concept of supermesh. A supermesh is simply a combination of 3 meshes, 2 or more than 2 meshes. All right. So I hope you have understood the concept. Let me end this session here.